Today we are looking at how chemical formula are written given their chemical names. And I'll even show you a very easy way to get the formula right every single time. Hey everyone. Okay, today we are going to write chemical formulas for ionic compounds. Now what are ionic compounds? Simply put, ionic compounds are those formed from metallic elements and non-metallic elements. Now if you remember your periodic table, the metallic elements are found on the left side of the periodic table, while non-metallic elements are found on the right. We begin with the name magnesium fluoride. Now the word magnesium refers to a metallic element. Locate this in the periodic table. I will assume that you already know how ions are formed from atoms. If you do not, subscribe to my channel. I will soon come up with a video for that. For the time being, look at this picture of the periodic table. I have listed down the charges of the ions formed by the elements. You are in fact recommended to add these notes to your own periodic table, as it will help you from time to time. Now, because magnesium belongs to group 2, it has a charge of +2, and fluorine belonging to group 7, it has a charge of -1. Note here that the word fluoride actually refers to the element fluorine. It may be a different word, but it refers to the same element. In order for magnesium to get a charge of +2, it has to lose 2 electrons. Imagine it lost 1 electron to the fluoride ion on the right. Magnesium still has to lose 1 more electron. So, another fluoride ion has to pick up the extra electron. So now the ratio of magnesium to fluoride ions is in a ratio of 1:2. Hence, the formula turns out to be MgF2, indicating that for every 1 magnesium ion, there are 2 fluoride ions within the same compound. Let's take another example, potassium sulfide. Again, this name is split into potassium and sulfide. Look up the periodic table for the potassium ion. We will see that it belongs to group 1. For sulfide, which is sulfur, it belongs to group 6. Hence, potassium forms K+. Sulfur forms the sulfide ion S2-. So now, potassium loses 1 electron to the sulfide ion. Sulfide ion requires 2 electrons. Therefore, another potassium ion has to lose an electron to it. The ratio for potassium ion to sulfide ion is therefore 2:1. And so the formula is simply K2S. Let's use this next example and revise the steps. Step 1. Separate the name into metal and non-metal. Calcium is a metal belonging to group 2, so it is Ca2+. Iodide, which refers to iodine, belongs to group 7, hence it forms I-. Consider calcium ion having to lose 2 electrons, hence it will lose 1 to one of the iodide ions and lose the other to another iodide ion, giving us the ratio of 1 calcium ion to 2 iodide ions. Guess what the formula is? CaI2. Now try this very simple example. Magnesium chloride. Go ahead, I'll give you some time. Are you ready? The answer is MgCl2. Did you get it right? Great job! Now, let's try something a little tougher. Aluminum sulfide. This is made of the metal element, aluminum, and the non-metal element, sulfide, which is sulfur. Now, aluminum is in group 3, and thus it forms Al3+. Sulfur or sulfide is in group 6, and so forms S2-. Now, aluminum has to lose 3 electrons. 2 of these will be lost to one of the sulfide. The next electron has to be lost to another sulfide ion. But of course, the sulfide ion requires one more electron. This has to be supplied by yet another aluminum ion. The other aluminum ion still has 2 more electrons to give, and it will supply it to another sulfide ion. This gives us the ratio of 2 aluminum ions to 3 sulfide ions. And so the formula is Al2S3. Let's consider calcium oxide. As usual, separate it into metallic element and non-metallic element. Calcium belonging to group 2 forms Ca2+. Oxide belonging to group 6 forms O2-. Now in this case, calcium loses both its electrons to the oxygen. This would give us a ratio of 1 calcium ion to 1 oxide ion. And as a result, the formula is CaO. Now the correct formula for calcium oxide is CaO. Some students would make the common mistake of writing it as Ca2O2. This is wrong. Another common mistake is to write it as Ca1O1. While you may think this is perfectly fine because this is a ratio of 1:1, but technically we should not be writing the 1. Take note. Let's try one last example before I show you a shortcut method to getting the formula right every single time. Let's try calcium nitride. As before, split the word into metal element and non-metal element. Calcium, being from group 2, forms Ca2+. Nitride or nitrogen comes from the group 5 and so forms N3-. The calcium will lose 2 of its electrons to the nitride ion. But nitride ion requires 1 more electron. So another calcium comes and gives its electron. This calcium will lose its other electron to another nitride ion. And another calcium ion has to donate 2 more electrons to the nitride ion. The result, you have 3 calcium ions to 2 nitride ions. And so the formula for calcium nitride is Ca3N2. Okay, now for the shortcut method, let me use the example of aluminum oxide. As before, separate the name into metallic element and non-metallic element. Aluminum from group 3 forms Al3+. Oxide, or oxygen, comes from group 6 and so forms O2-. Now what we do that is different is to duplicate the symbols beneath but without the charges. Hence we write Al below Al3+, and we write O below O2-. Take the 3 from the Al3+, and cross it over to the O on the other side. We'll do the same for the oxide ion O2-. We grab the 2 from the O2- and cross it over to the Al. This immediately gives us the correct formula, Al2O3. Let us try barium oxide. Barium from group 2 is Ba2+. Oxide or oxygen is from group 6, so it's O2-. We write Ba below Ba2+, and we write O below O2-. Now cross the number 2 from the Ba2+ over to the O below, and cross the 2 from O2- to the Ba below. Now although this gives us Ba2O2, this is not our answer. Remember, we are dealing with ratios here. So if it is Ba2O2, we should write it simply as BaO. Now I have seen this common mistake being made. When using this method, some students will actually forget that they are supposed to cross the numbers over to the opposite element. So instead of writing Al2O3, they end up with Al3O2. This is wrong. Remember the method. You are supposed to cross the charge of one element over to the other element at the bottom. Let's try this method on magnesium chloride. Magnesium from group 2 forms Mg2+. Chloride or chlorine from group 7 forms Cl-. We replicate the symbols down below. So we write the symbol Mg beneath Mg2+ and Cl beneath Cl-. Now we cross the 2 from the 2+ over to Cl below, and we cross the 1 from the Cl- to the Mg below. This gives us the correct formula MgCl2. I hope you found this video useful. Remember to click like if you do, as it helps me a lot. Leave your comments down below if you think you can write chemical formula more confidently now. And remember to subscribe to my channel to be notified of upcoming videos on various topics of science and math. See you next time!